Let's have a crack at exercise 3. I'm going to do a video for each of the parts of exercise 3 because there's lots of them. If we look at the little mini map over here, each of those big yellow chunks is the explanation of each function, and the requirements are written in the doc strings. So let's go up to the top here and have a look at what the first one is. The first function here that we have to write is a function that tests if a number is odd. And there's a tip here. It says look into modulo division using the percent operator as one way of doing this. Now, it's asking us to return true, which is the Python Boolean value, if a number is odd, and false is if a number is even. So that's something to bear in mind for later, because one of the big mistakes that people make is trying to return true if a number is even, because that's easier to do. Okay, when we get to parse here, parse is just a thing in Python that says, hey, don't freak out when you get to this indented block because there's nothing here. We're going to write parse just so it says, hey, don't worry about things. So you want to remove parse as soon as you put in any real code. Parse is just there to stub things out so it doesn't freak out. In other languages, you'll see people doing stupid stuff like 1 + 1. And so there's a statement there and it's not complaining. But Python's being a lot more explicit and saying parse so that it's like, oh, okay, I know what to do here. So let's have a think about how to test if a number is even or not. We did it in class, but let's do it again here. So let's think about what's going on here. Let's print 2 divided by 2. Because to me, anyway, the way I think about even numbers and odd numbers is whether it's divisible by 2. If it's divisible by 2 with no remainder, then we'll get, it'll be even. If it's not divisible by 2, then we should get an odd number, like a partial number. So let's run that, and then Control-Shift-B. Now we get this little thing like mini tests at the bottom here. So the bit that we've just written is the little bit at the top here. The mini tests are there to help you while you're running. And so none is odd, 1.5, blah, 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 blah. Doesn't matter. Ignore that for the moment. That's just to help you out so you don't have to run the big tests all the time. It's just to speed things up. But we see that 2 divided by 2 gives us 1, which is a whole number. And 3 divided by 2 gives us 1.5, which is not a whole number. So there's some remainder. This 0.5 is the remainder. So if I try and swap these two divisions for modulos and then run it, so it's going to complain that I'm missing the white space around an operator because it's modulo is an operator. There we go. Plus is an operator too. I don't really understand why it doesn't do that. Anyway, let's run that. Control-Shift-B and then have a look here. So modulo division for 2 and 2. So 2 modulo 2 gives 0 because there's no remainder. And 2 modulo 3, or 3 modulo 2, sorry, gives a remainder of 1. There's 1 left over when we divide as many 2's as we can into 3, which is 1, and then there's 1 left over. This stuff is so simple that it's actually kind of hard to get your head around because you're thinking that there must be something else going on here, but really it's just super, super simple. So in our case, our number is the number we're being given. So we want to test if our number is modulo 2. So modulo 2 equals 0. So if we run this now like this, we want to get rid of that pass and then start returning something. Return number. So we get the autocorrect, get it to do the work for us. Our number modulo 2. And so now that will give us a 0 or a 1, depending on what that number is. Okay. We want to know if it's odd or even and return true or false rather than 1 or 0. So we want to return, we need to do a Boolean test. So if that is equal to 0, then that will be fine, except it will return true if the number is even, not if the number is odd. So our number modulo 2 equality test, double equals for equality, not single equals for assignment. So double equals for equality, 0. So if we evaluate just this section, and let's pick a number for our number. Let's say it's 2 modulo 2. So 2 is an even number. Modulo 2 gives us 0. That is equal to 0, which means that it's not odd. So we've got our logic flipped here. So let's try it again with an even number, an odd number, and just check this out. So if our number is 3, 3 modulo 2, that's going to give us 1, right? We just saw that here. So 3 modulo 2 equals 0 is false. So our logic is flipped. So we can flip that by checking for not equals to. So if it's not equal, now I've got my fancy programming font here, but that would come out on your computer like that, but without the space. Okay. So we want to check that any number modulo 2 is not equal to 0, and that will return a true or false value. Now I like to put these things in brackets so that we know that that bit evaluates first, just because it makes my life a bit easier in terms of readability. It actually makes no difference to the execution whether that is or not, because of the way that the BODMAS order of precedence works. So let's see if this actually runs. So if we do the mini tests, and we can say true, odd, yeah, true is odd, so it is odd, false is even. So true is odd, false is even, so that's good. So I'm going to stop here and I'm going to run the tests, but by now you should be okay running your tests on your own. I'm going to run the tests, and if it passes I'm going to commit it, and if it doesn't pass I'm going to come back and have a look.